Today on How It's Made. Motorcycles. We'll take you to the factory where production goes in cycles. Clay pipes. Making them is an underground business. Drumsticks. We could bang on about this forever. And whistles. A thrilling story that'll blow you away. But first, the invention of the motorcycle in the late 19th century was speed-driven. People wanted to go places faster than they could on a bicycle, so they strapped an engine on a bike. A simple concept. Today's motorbikes are far more complex, and they leave the earlier versions in the dust. These motorbikes are an engineering feat. They start by welding the frame out of lightweight aluminium, an advantage for speed and fuel efficiency. The frames are cleaned, powder painted, then baked to cure the paint. They fit a crankshaft and pistons into the engine's left block. They tighten the bearings and caps, then slide in a U-shaped tool called a fork that orientates the pistons in an upright position. Next, they compress the piston rings with another tool so that the pistons easily slide into place as they install the other half of the engine block. They place a gasket on the top of the block and then install the cylinder head. Using torque-controlled electric tools, they tighten the bolts to attach the cylinder head to the block assembly. They install the camshaft in the cylinder head unit. The camshaft will drive the valves that bring in air and fuel and let out the exhaust. They rotate the crankshaft to fine-tune its action. Now it's time to give this engine a test run. They fill the engine with coolant, lubricant and fuel, then run through the gears. They check for leaks and overall function. When it passes inspection, they purge the coolant from the engine. A motorbike engine isn't only about function, it also has to look good, because it won't be totally hidden under a bonnet. Now, they lower the 102-kilogram engine onto a cradle that sits on a conveyor. They mount the frame onto it. They attach the rear wheel assembly, and then the front. They attach the handlebar, using the correct amount of torque. And they tighten the brake assemblies. Next, they fill the radiator with antifreeze. Meanwhile, over in the paint department, robots are hard at work. They attach the painted pieces to the bike. First the saddlebag body, then the lid, and finally the trunk body. Then they assemble the instrumentation, such as the speedometer and fuel gauges. This part is called the front cowl, and it goes in front of the instrumentation. They lower the front cowl with the meter panel onto the bike. And then they bolt everything to the frame. Finally, they install a cover for the exhaust pipe. They check everything to make sure it's solidly put together. Then they pull up to a dynamometer, a machine that measures mechanical power. They check the bike's speed, brakes, horn, navigation system, and the cruise control. Every motorbike undergoes this scrutiny, and if it passes, it's ready for life on the open road. Clay pipes are part of a major underground network, one that's dedicated to proper drainage. We flush without thinking, but it may surprise you to learn that clay pipes have been serving us well for thousands of years, ever since the days of ancient Babylonia. They're the sanitary sewer system's oldest secret. These pipes can take a lot of stress. They bear the weight of soil and structures overhead, and they won't corrode. They start with scrap clay from manufacturing, raw clay, and shale. After these materials have been roughly processed, a loader scoops the mix onto a conveyor that takes it to a mill for a finer grading. At this point, the mix has about 10% natural moisture, but it's not enough for it to stick together. So they add more water as it falls into a mixer. The mixer evenly distributes the water in the mix, then moves it towards an extruder that pushes the clay through a pipe-shaped die. The clay pipe that emerges is 20 centimeters in diameter, the size that typically serves a residential side street. It has a bell-shaped opening. It's the female part of the joint that will fit into the male end of another pipe. A rotating blade trims away the ragged edges. Then, an automated system loads several pipes at a time onto a rack to await the next step. Over on another production line, they're making flue liners for chimneys. The clay is fairly soft at this point, so lettering wheels can easily engrave information. And they cut it to size, using thin wire. An upender stacks it on a pallet to await further processing. Elsewhere in the plant, a main trunk sewer pipe is born. With a diameter of over 38 centimeters, it's big and needs a substantial trim job to get rid of the rough edges. It weighs well over 300 kilograms, nearly 5 times that of the residential pipe. Once they're fabricated, every clay pipe goes into a dryer for at least 24 hours. A trip through a kiln will toughen them up even more. They'll spend about 50 hours in here, exposed to very high temperatures. This is called vitrification. It fuses the mineral particles together. They tap each pipe with a hammer to test if it's solid and perform a thorough visual inspection. To join lengths of pipe together, they pour polyester resin into the female joint molds that have been placed in the bell-shaped pipes. The resin hardens, forming an O-ring, and the primer brushed on earlier helps the new resin joint adhere to the clay pipe. Next, they make a male joint by pouring resin around its spigot end. This will make for a joint with a tight seal. They test the joints by pumping water into the pipe. Then they raise it and place a load on the joint. This joint will withstand over a metric ton of pressure, which more than meets industry requirements. Now, they do another type of test on a basic clay pipe. A hydraulic jack applies pressure on the pipe. The number on the gauge far exceeds the burden of being buried underground. And so these pipes are now ready for civic duty, down in the sewers. Coming up on how it's made, drumsticks. We're on a roll with this one. And whistles, for all you referees and ravers out there. See you after the break. Drumsticks are designed for a life of hard knocks. They're usually made of hickory, which is heavier and sturdier than other woods. Hickory can also absorb a lot of shock, which means a drumstick made from it is easier on the hands and wrists, so the drummer doesn't have to suffer for his music. Hickory drumsticks also have good balance and feel, so it's easier to hit the right note. To make them, automated arms serve up hickory dowels to a 3-bladed cutting device that moves on a rail. As the blades shape the spinning dowels, they form a round tip, a narrow shoulder, and a shaft that gradually widens. They spray each stick with a protective coating. These round blades remove the stubs, the ends where the sticks were held during the initial machining. It's just a rough trim, and the ends need more work. So they feed them to spinning chucks with blades. The chucks are inside protective metal housing because they spin very fast and the blades are extremely sharp. For a demonstration, the housing on one of the chucks has been removed and they turn it by hand. The chuck usually rotates at 10,000 RPM, but at this slow speed you can see just how it shaves an end into the desired shape. The stick comes out of the chuck with a nicely rounded tip. Now, they test the sticks. Each one rolls down steel rails that have been specially aligned. If it rolls straight, it means the stick is straight, but if it wobbles, it isn't and would be impossible to play with. They reject those sticks. Next, a printer embosses the brand name and model number onto each of the drumsticks. Now, they sort each drumstick by weight. Even if two sticks have been made exactly the same shape and size, their weight can vary because wood has different densities, and that's something that affects the stick's feel and tone. For example, this drumstick weighs 53 grams, but the next one comes in at 55. Over at another workstation, they're making a different kind of drumstick, a felt-tip mallet that will have a softer sound. They press a wooden shaft into the glue-filled hole of the felt ball. The hole is a bit smaller than the shaft, resulting in a tight bond between the stick and the felt head. They do a sound check on the other sticks. Even though they've been sorted by weight, there are still subtle differences in tone. A computer analyzes their sound and matches pairs. It's a bit like a dating game. The unmated sticks go back into the mix, and then they try to match them up again. This matching process is critical. If one stick has a different pitch, the sound will be off balance. They assign a numerical value to each pair of drumsticks. A cardboard sleeve holds each matched pair together. From a rough wooden dowel to a sleek drumstick, a process that's designed for impact. When you blow into a whistle, part of the airstream exits the slot in a swirling motion, generating sound. The rest of the airstream travels through the whistle chamber, then exits the slot, reinforcing the sound. And if you've ever wondered why it's in there, the little ball inside puts the trill in the whistle blast. Production begins with a narrow brass sheet, not quite a millimetre thick. A punch press slices through the sheet, cutting a square connected to two circles. The factory calls these pieces the Mickey Mouse ears. I wonder why. One by one, they go into a second press that folds the circles inward to form the sides of the whistle's barrel, and bends the edges of the square inward to form the top and sides of the mouthpiece. At the same time, it strikes the mouthpiece against a die that embosses the company logo into the metal. Another brass sheet feeds a third press. This machine punches out and partially shapes the part that forms the rest of the whistle. It notches the tapered end, which will be the underside of the mouthpiece, giving your teeth something to grip. Now a fourth press finishes shaping these pieces. It bends the other end into a circle to form the barrel. The two main parts of the whistle are now ready. A worker snaps them together with pliers. Note on the bottom piece, the barrel stops short of meeting the top of the mouthpiece. This creates the whistle's air slot. This press cuts and folds a brass sheet into the third and final part of the whistle, called the tip. It's a piece on the back that holds a ring for hanging the whistle. The tips go into a bowl feeder. The vibration orientates them into the same direction, so that a robotic arm can pick them up and put them in a holder. Tin and silver solder is applied to each tip. This will bond it to the whistle. To fuse all the parts together, solder is applied in 6 different spots. The solder liquefies as a gas flame heats it to 600 degrees Celsius. It flows around all the seams, filling them in a matter of seconds. A blast of cold air solidifies the solder. Even then, it's still steaming as the whistle comes off the machine. The ball that goes inside the barrel is about 1 centimetre in diameter and made of synthetic cork, which doesn't absorb moisture, so the ball never gets soggy and stuck. A worker holds each whistle, now plated with nickel, against the insertion machine. The device works like these pliers, squeezing a ball through the whistle's air slot. With one side of the barrel cut away, you can see how the ball regains its shape as soon as it clears the slot. The last step is to hook a steel ring onto each tip. The factory packages its whistles with a nylon cord, called a lanyard. A hook on one end attaches it to the whistle's ring. Another accessory in the package is a rubber cover for the mouthpiece. It makes holding the whistle in your mouth for a long time more comfortable. This factory also makes customized whistles. You can order them with your own logo. Or to really blow someone away, you can present them with a 24-carat gold-plated award whistle. So, whether you want to get out on the highway, or you're interested in how the waste gets washed away, or you like to spend your time banging away, now you know how it's made.